Hello everyone, good morning to you all. This is Dr. D. Srinivasa Rao, working as Associate Professor in the Department of Information Technology, VNR VJEC. Today I am going to be explaining you the topic titled Introduction to Distributed Database Systems from the subject titled Distributed Database Systems. The main agenda of this session is to know about distributed databases, its purposes, applications, advantages, disadvantages, and challenges to be addressed. Distributed databases is also correlated and associated with the distributed computing, where processing logic, functionality, data usage, and control over the processing is going to be distributed. Distributed computing is going to be solve the complex problem by decomposing into submodules, and each module is going to be processed at a individual level, whereas distributed database is going to be share the processing data and which is to be executed in parallel manner. The real-time usage of distributed database seems to be the data available at different physical locations are going to be processed in parallel by make use of their local software. Distributed database is a collection of multiple logically interrelated database spread over the computer network. Logically interrelated database says about the data belongs to a particular context. Example, if talking about employee database, where employee, project, assignment, budget, all these are derived from the employee database. The sub modules of this particular database is logically connected, whereas distributed DBMS is the software that manages the distributed database and which is used to manage, storage, manipulate, and retrieve the data based on user need. Distributed database is actual repository of the data, while distributed database is the software that manages, manipulates, and protects the data demanded by the user based on the context. In a sense of interpretation, the distributed database is the books spread over the multiple physical locations, whereas DBMS is the master librarian who capable of tracking and retrieving the data required in the context. The core difference between distributed database and database management system is that the distributed database is the physical collection of files, tables. It is also called relations in RDBMS. The records, which are the part of the relation, split up and stored across multiple geographical locations like Hyderabad, Mumbai, New York, and Rome. Whereas the DDBMS is the software applications running on these nodes that coordinates user requests that capable of working on the data available locally and ensures security from the unauthorized access and also provides consistency, which is the important requirement in the database system. How the DBMS software is distributed. In distributed database system, we don't have one central software installation, whereas the software architecture splits into two main layers titled local DBMS component and a global distributed component. Local DBMS component is required that manages the specific data files physically stored on the system and which is used to work on the local data available, whereas the global distributed component that runs on communication and coordination layer that capable of routing queries across the network and ensures data stays synchronized at multiple places. Because of these two layers, the distributed DBMS is capable of doing its objectives specified, through which the real purpose of distributed database working fine. Here, distributed database also associated with two types of software models, which are titled homogeneous and heterogeneous. As the name implied, that homogeneous system is same software which is installed at all the locations. For example, every node runs on Cassandra, or every node runs cockroach databases. Thus, MySQL is installed at all the physical locations, or Oracle is installed at all the physical locations, through which we could manage all machines speak the exact same language where the translator is not required. Whereas the heterogeneous systems, each physical location is associated with different DBMS, like Oracle at node A, MySQL at node B, and node C runs PostgreSQL. The purpose of them is to working on different types of database systems which are required by the user at different context. Though it is the heterogeneous systems, because of the translation layer that specified and which is interpreted as homogeneous system without giving the hurdles to the end user. What is the purpose of distributing the software? What happens if the software is not distributed? If you have spread data across network rather than storing at one place, we too manage data at different physical locations. We can run the queries in parallel, and we can work on the data available on locally. Is going to be reduce latency, is going to be encourage us for parallel execution. In that setup, the single computer running on the software crashes, the entire system should halt. Example, if the data is available at one place and all the users depends on the same location, whenever the particular systems goes down, the entire system will be halted. Rather, a true distributed DBMS distributes the software so that if one data crashes, the other nodes and other locations are available with the data required. They are capable of continuing the processing. This particular distributed database is different with distributed computing, which is also the facility available nowadays in computing era. Distributed computing is the model where the independent computers solve the massive problem together, where the complex problem is decomposed into multiple subproblems, and each location is capable of working on the given subtask. Whereas the distributed database system is a specialized subcategory that focuses on storing the data at multiple locations, managing the data in a synchronized fashion, and which is capable of executing queries in parallel, and that happens across the world and which is connected over the internet. In the broad sense of difference, the distributed computing focus on splitting of computation, processing like usage of CPU, usage of logic built, and usage of tasks to be worked together. Whereas the distributed database focus on splitting of the original data, its storage, its retrieval, connected to disks in the form of tables, conducting transaction processing, and achieving the properties of the transaction properties like atomicity, consistency, isolation, and durability for the successful data management for the end user. In the true distributed databases, both data and the processing elements called DBMS software are distributed across multiple locations. Data is distributed. The pieces of the database live on different physical machines across the world. In addition to that, the DBMS is also distributed. Every machine runs its own local DBMS software to process the local data, and they communicate with the other nodes, and it is giving the illusion that it's a single system and single software that manages all the data and all the sub-softwares, and it seems to be a single state to the end user. Now we will see the real purpose of a distributed database. Here, the distributed database is to provide reliable, fast, and scalable data accessed by physical distributing nodes. Reliability stating that if one location comes down, the rest of the locations are available to run your system to process the query received from the user across the world. As the local data is available, the local software is available, the processing is faster. As data increases, we have the facility of adding it to the existing database with the physical independence, logical independence, so that we can consider enhancement of the database. We can continuing the parallel execution of the queries received from different users across the world. It solves physical limitations of scaling up a single central machine where the data is stored at one place and all the queries, all the users need to contact this particular single system. If it goes down, the processing is not possible, entire system should be halt, where we are losing the reliability, we are losing the scalability, which is available through distributed database system. There are three ways of systems distribute components in the real world used in different purposes, titled true distributed databases, where the data and processing are distributed. Second one, centralized database with remote access, where only processing is distributed but data is available at one place. Third one, network attached storage, also called shared disk, where the data is distributed but processing is available at one place. Now we will see the differences among these three categories. First one, the true distributed database. This is our real titled, which we are discussing, where the data and processing are distributed. What do you mean by distributing data? The data is partitioned to reduce the load, to encourage the parallel execution, to speed up the processing, to support the scalability, and we are going to be provide the facility of accessing the data and retrieving the query response in a faster manner. With the partition and replication of the data at multiple machines available at different locations, and each machine has their processing capability. Each machine is equipped with their local DBMS software, is capable of processing the data locally available. Here, if you ask machine A for data stored on machine B, with the transparency, the machine A DBMS is capable of communicating with the machine B's DBMS and to get the data from that and giving it to the user connected to machine A. The real environment where this particular distributed database available with the software titled Google Spanner, Apache Cassandra, and Cockroach DB is capable of working with the distributed data and distributed processing capacity, and they are supporting to define and to justify real distributed database concepts. Second aspect here it is centralized database with remote access, where the processing is distributed but data is available at one place. What it is that the data lives entirely on one big central server. This central server stores the data at one place, And if this particular server goes down, the entire system to be halted. Here, the processing is only distributed. Here, multiple users or applications, processing elements, and each DBMS software available at multiple physical locations use their own computers or servers are capable of processing their queries called run queries, but they all send requests to that single central database where network requirement is the primary criteria and latency is the big problem. The data itself never moves. As it is available at one place, only the queries are submitted to single server, execution takes place at the same server, and data retrieved and query response is retrieved from the server and it is submitted to the required user. The third category is network attached storage, also called shared disk, where processing is available at one place, only the data is distributed. So, whenever the query to be executed, the data to be moved to that particular location where the software is available. Though data is distributed into multiple physical locations, whenever user submitted the query to the individual location, this particular query to be forwarded to the single central server where processing facility is available. The data is spread across network storage drives, but there is only one central database server to which these queries to be submitted, received from the different users across the world. The processing is centralized in one computer, but it reads and writes to disks spread across the network. Through this centralized computer, you are able to process the query and providing response to the query and submit it to the nodes which are scattered across the world. Whenever this particular single database server happens to down, the entire system to be halted till it comes to normal mode. There are key operational purposes of distributed databases, also called purposes of distributed database. In order to provide high availability and fault tolerance, low latency, low access, to provide horizontal scalability, and to provide organizational reflection, distributed database is required. High availability. So whenever user needs the data, whenever user needs the response to their query, they to get it 24/7 by 365. It is called high availability. Though one of the node happens to down, the rest of the nodes are available to take the user request and to provide response to them. It is also providing fault tolerance, ability to tolerate with the faults. Faults are unavoidable, but that system have the tolerance capability, ensuring the system stays online even if hardware component fails. If a single server or entire data center crashes, the background replicas is available that can take over to avoid the downtime of the particular node and particular software. So when one system happens to down, rest of N-1 systems are available to take the user needs and to provide the responses to them all the time. And the second advantage of distributed database is low latency and low access. The placing the data physically closer to the user so that network requirement can be reduced, latency can be reduced. By storing European user records in Europe, maybe at Rome City, and Asian user records in Asia, maybe in Mumbai, Applications bypass the long distance transitic network delays so that the local queries executed at local nodes where the local data is available and local DBMS software is available. One more advantage of distributed database is to provide horizontal scalability. Growing the database as on day happens, as data increase going on, the adding of cheap standard servers to the cluster existing instead of buying an expensive specialized supercomputer to meet the requirement dynamically. This lifts the storage and processing ceilings infinitely. With the physical independence, logical independence is possible with the distributed database that happens continuously, dynamically, without handling the current executions and the data available as of now. Last advantage of distributed database system is organizational reflection. This reflection states matching the decentralized layout of modern companies existing at physical locations scattered around the world. It separates the corporate divisions can operate and maintain local control over their own data nodes while still participating in the global network. Example, customers' data at one location, orders at one location, invoice at other locations, but still all of them are connected over the internet and they are working in a synchronized manner, and consistency is defaultly available. Here, these are the different critical real world applications where distributed database system is used without any hurdle. The global financial and payment networks supporting distributed database principles and asking for its facility where the payments happens seamlessly without hurdle and is going to be compute the query is associated with multiple nodes, multiple softwares available and scattered across the world. All online payment systems happening with the three-tier architecture like client, banking system, and third party is going to be synchronized this client with the banking system. And one more real-time environment where distributed database system is required is that the massive e-commerce marketplaces, example Amazon, Flipkart, are using these distributed database principles anonymously to support their customers and to provide the better facility to them. And on-demand content streaming, example, the OTT platforms are also using the principles of distributed database system and used to provide on-demand content streaming where content is available at multiple places, are requested by different users and are able to connect them as a single system and with all types of transparency because the great advantages of distributed database systems. And one more well-connected application with all the users is social media and communication networks also using the principles facilities of distributed database system where users are scattered around the world but are connected over the internet through heterogeneous systems through they are capable of sharing the data, sharing information in different forms like text, audio, video, and animations. One more application of distributed database system is ride-hailing and logistic systems which are connected seamlessly and are able to process their functions continuously and giving the illusion that single system, single software is working for this particular need. And the last application of this particular system is industrial IoT and smart grids are using distributed database principles continuously, and they are capable of providing best facilities to the user at different contexts. Though we have different needs, different advantages, and critical applications where distributed database systems are available and using a different context, there are some challenges to be addressed, to be handled, to provide a seamless interface to the end users that maps the hurdles and are going to be handle different types of transparencies where complexity is converted into convenience, which are titled the consistency and the latency. The consistency is to synchronizing the global replicas introduces network delays and prioritizing the speed that can result in nodes serving the stale data where executions are possible without delay and responses are given to the user dynamically and ensuring the consistency of the data available at different locations at different physical nodes. Then network partitions is the important concept where the distributed database principles to be addressed, that the physical network drops isolate nodes, it forcing a choice between system uptime or strict the data accuracy. Here we are going to be decompose the complex database into multiple sub databases, storing it to multiple physical locations, and we are going to be use all these submodules to provide responses to the queries received from local users, and it is also capable of working on global query. Then third challenge to be addressed by DDB is transaction coordination that guarantee ACID properties safety across separate servers available at different locations connected over the internet that create performance bottlenecks. Then to address the clock synchronization, when we consider Asian continent, European continent, American continent, African continent, different continents are using different clocks. We need the global clock to achieve clock synchronization where transaction processing, tracking, and retrieval to be happen associated with the global clock. Then next challenge to address is partitioning complexity. So partitioning the global data, partitioning the global query is the greater challenge, where the poorly designed data fragmentation leads to uneven server loads, overloaded, medium loaded, and low loaded are the three categories are the result obtained from uneven server loads and expensive cross nodes lookups. So uneven server loads is going to be face the problem like latency, network usage that yields to expensive of the maintenance of the overloaded server compared to low loaded server. Then the one more challenge to be addressed by DDB principles is that the larger attack surface where transmitting and storing the data across multiple locations increase security risks, where we to address each every problem addressed by the local query related to the local database storage, execution of the local query. And as long as physical locations are increasing, as long as the size of the data is increasing, as long as we are adding distributed DBMS softwares, and we are also supporting heterogeneous systems, we to provide the transparency to the end user, and V2 provides security and protection to the user's data without any hurdle. Then query optimization is the important task in DBMS software, where V2 execute the query with the minimum cost. Includes network related, computing power related, logic related, CPU's powers related, memory cycles related. The greater challenge of query optimization is well handled and in the distributed database systems. Then the last challenge to be addressed by distributed database is that infrastructure overhead. Scaling means increasing horizontal demand, adding the database servers, adding the DBMS softwares needs to handle high network bandwidth, yields to complex monitoring tools, and specialized engineering labor is to be considered to provide a greater experience to the end user. So what is not a distributed database system? A time-sharing system is not a distributed database system. A loosely or tightly coupled multiprocessor system is not a distributed database system. A database system which resides at one of the nodes of the network of computer, this is a centralized database on a network node. So, time-sharing system, multiprocessor system will not come under distributed database systems. Thank you for your attention.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.